sure after last lesson you're thinking, what? This is weird. This is supposed to be about math, and I'm looking at all these words, like kind of like English or science. But here comes the math part of geometry. So you have kind of a lot of geometry is kind of wordy, you would say. So there's lots of things you'll see here that are less mathy, is probably than what you've seen in the past. But there is a lot of math still in this. So just some quick vocabulary review. When you say something has equal distance, you say equidistant. So you would say, so two objects are exactly the same distance, then you would say equidistant. And then this little symbol here, it has the equal sign with the little squiggle above it. That is going to be congruent. That is very, very important that you remember what that sign is. This is the ruler postulate. Measure the length of a segment. You can use a number line to count the distance between the two endpoints. So if we were to find the distance between -2 and 6 on the number line, you would draw your number line here and label it off. Okay, and then I can put my 2 points on there, -2 and 6. And then I could count the distance in between there. So 1, 2, 3, 4, 5, 6, 7, 8. So the distance between -2 and 6 on the number line is 8. Now, something you definitely want to make sure you remember is that all the distance has to be positive. When we talk about distance, we're talking about positive. Just because I run 2 miles down the road and 2 miles back doesn't mean I ran 0 miles. I ran 4 because I ran down there and back. So distance has to be positive. So make sure you kind of remember that. Okay, so we're going to find the measurement of PQ, of QR, and then PR from this number line. So you'll notice that each little tick mark is actually a half. So you want to kind of pay attention to that. So if I'm counting in between there, this is a half, this is 1, this is 1.5. So between P and Q, it's 1.5. Between Q and R, so we have, here's 1 and 2 and 3 and 4.5. So each one is 0.5. So 4.5. And then to go from P to R, then I will have, let's see here. This is a half. That's 1.5, 2.5, 3.5, 4.5, 5.5, and then another half is going to make 6. All right, so based on the ruler postulate, I can find the distance of AB, or find the measurement of AB, if I take the coordinate of A, which is -2, and I subtract the coordinate of B, which would give me, so then those two little bars means absolute value. So absolute value means the distance from 0, which means it's always going to be positive. So I'll take the absolute value of -2 minus 5, which is actually -7. So the distance between 0 and -7, even though I'm going backwards, is actually +7. It's like me running, if I run 2 miles down and 2 miles back, I ran 4. When I ran back, it was still 2 miles, okay? I still felt it. So this is a +7 here. So the distance between -2 and 5, instead of counting it, because what if it's 200 down the line? You're going to be like, 1, 2, 3. No. So just, you can take the first coordinate and then subtract it from the second coordinate, and you're going to find the absolute value, because remember, distance has to be positive. So using that, let's find these distances here for PM. So to go from P to M, I'm going to say that is the absolute value of -4.5 minus -3. So minus -3, remember, becomes like +3. So this is the absolute value of -1.5, which is going to be a +1.5. To find the value between L and N, so L is at -1 minus 5.5. the absolute value of that. So then that's going to give me a negative 6.5, which taking the absolute value of that is going to give me a positive 6.5. And then between R and M, so it looks like we're moving backwards, but RM and MR doesn't matter because remember, distance is still positive. So I'm going to go from, R is at 0.5 minus negative 3, which is like plus 3. So that's the absolute value of 3.5, which is just 3.5. So I know that before it looked like we just flipped we just made whatever was negative, made it positive. We just flipped the sign. Well, if it's positive, it stays positive. But if it's negative, it turns to positive. All right, so remember that we found the distance by finding the absolute value from point A minus point B, and remember that ended up being a positive value. But now we're going to find the midpoint, and we're going to find that by taking A plus B and then dividing it by 2. So wherever the point is for A, and then adding it to point B, then dividing by 2, that would give us our midpoint. So then we're going to find the fractional distance by taking K, and we're going to multiply that by the absolute value of our, basically the distance there. So that's going to be, A minus B. And so we're going to multiply that by there, and then we'll have to see where that fractional distance needs to end up at, because sometimes it takes us to the wrong place. So we just want to make sure we're there. And then K is a fractional distance. So let's look at the midpoint. So in the midpoint, I'm going to take this. I'm going to say A plus B divided by 2. So that's a negative 3 plus 5 divided by 2. And so that is going to be, this is 2 divided by 2, which ends up being 1. So our midpoint here is 1 between A and B. And then the midpoint between C and D, that's going to be C plus D divided by 2. So C is at negative 7 plus 3 divided by 2. So this ends up being negative 4 divided by 2, which is negative 2. So my midpoint here is there. So you can see that the distance there between those two is exactly the same. Now, the other part of this is the fractional distance, and this is a little bit more challenging. So I want to find the point at 3/4 of the distance. So I first need to let's go ahead and find the distance. So the distance is going to be negative 7 minus 1. So I got used to midpoint and add a plus. So this is going to be the absolute value of negative 8, which is going to be positive 8. So from here to here is 8. And then we want to find 3/4 of that. So we're going to go with 3 divided by 4 times 8 over 1, which is 24 over 4, which is 6. So my point here, so I don't see a 6 on here. Well, what we're saying is that the fractional distance 3/4 of the way is 6. So I'm going to go 6 units here, and it's going to be here at negative 1. So my answer here is negative 1, not 6. The fractional distance is 6. I then need to take that from my point and go that far and count the fractional distance there. Let's look at the next one. We have a 1/5. So that's going to be our fractional distance. So I'm going to take the absolute value. I'm going to find my distance first. So I'm going to say the absolute value of negative 8 minus 2 is the absolute value of negative 10, which is a positive 10. So this distance between here and here is 10. Then I want to find the distance that is 1/5 of that. So therefore, I'm going to say 1/5 times that distance, which is going to be 10 over 1, which is going to be 10 over 5, which is 2. So I'm going to go 2 units this way, and here is my 1/5 of the distance there is going to be at -6. So you can have a negative answer on midpoint and fractional distance, but you cannot have a negative number or negative answer on a distance, just straight distance. That's always going to be positive because you're going to use the absolute value formula for that. So these are a couple of formulas that you need to get used to and get prepared to use quite frequently because you're going to need them quite a bit. So remember we talked about distance being positive, using absolute values. Remember that just means positive all the time. Even if it is already positive, stays positive. And we talked about midpoint. You're going to take the 2 points, add them together, divide by 2. And then for the fractional distance, you're going to take that distance, absolute value, multiply it by your fractional distance, and then count, and then that will be the distance forward that you'll count to find the actual point. So we're not finding just the distance of it, we're finding the point that is at the fractional distance. So that's what I have. That's what this first unit is kind of, so that's what I have for you for line segments, midpoint, and fractional distance. We're going to use this a little bit later in the future, so hang on to it. Don't forget about it, and you'll be good to go.